All right. Hey, everybody. This is the Unit 9 Waves in Sound Review Guide. So real quick intro. This is kind of a new unit. We're going to deal with a new type of physics called waves. Waves transfer energy from one point to another without actually transferring any mass from that point to another. Now, mass still moves. The medium vibrates back and forth through simple harmonic motion, which is what the first few equations here. But it either vibrates perpendicular or parallel for a small area, while the wave itself, the energy, travels greater distances. So that's the first little bit there with those equations. Make sure you can calculate the period and frequency of something. Again, the ones on your equation sheet are right here, but then you have the actual other way to calculate it based off their ideas over in the other set there. So that's the vibrations and oscillations, which waves are a type of. And then we get to actual introduction to waves here. So make sure you can draw transverse and longitudinal waves, and you can label the different parts of those waves. And then next part of calculations, speed of wave. Make sure you can differentiate the idea of calculating velocity and speed of waves based off frequency, wavelength, distance, and time versus understanding what affects the speed of the wave. So the actual effect on the speed of a wave is based off the medium and type of wave. The medium, whereas calculating how fast it's going, you can use distance and time and frequency and wavelength type numbers to calculate it. But determining it is affected by the medium itself. All right. Then we get into the things that waves do. So the first one there is Doppler, right? Wave can change its frequency based off motion. That's the Doppler effect. Waves can reflect. Waves can interfere with each other, and waves can resonate. And so that's the last little bit is resonance. Now, resonance on a string and resonance within a tube. And that's the next time we have some mathematical equations there. Key equations here are the wavelength for any given harmonic. That's true for both a string and an open tube. So n is the number of harmonic, 2 times the length of whatever it is divided by that harmonic. And then the other big idea here is that the frequency of any harmonic is just a multiple of the fundamental or first harmonic there. So those are the two big equations there. The other ones are just for kind of simplification, but I would use those main two right there. Those would be the ones I'd focus on doing. All right. Welcome to the first video, and I will see you guys on first page.